They ask you to do the reverse of this, namely, here's a graph, write an equation that would produce it. And notice how it says the word write an equation. The reason why they don't have the word the there, because the or the usually means that there's only one possibility. There's only one answer you could have for that. And the fact of the matter is, that's not the case for this. Because, I could have several different equations giving the exact same graph. And some of those equations might involve sine, some of them might involve cosine. There's decisions I'm going to be making along the way that actually, lets me decide, what a proper equation is going to be. So this first example, I'm going to show, for part A, I'm going to show 4 different equations that would all produce the exact same thing. I still kind of work in reversal here. I want to figure out what the period, baseline, and amplitude are. I can see each one of those from the graph no matter what. I can see that the amplitude is 2, I can see the period is 2 pi over 3, because if I look at the graph there, it takes a little bit of time for me to realize, but I move 3 units to get to pi over 4, which means I'm moving by pi over 12s. And if I count between that highest point and the next highest point, I move 8 pi over 12s, which is the same thing as 2 pi over 3. So the period's 2 pi over 3. The baseline, I look to see where the highest and lowest point is. I just basically, I take the highest y value, the lowest y value, and I average them. That'll give me the baseline. This here, the baseline is 0. So y equals 0 is the baseline. As far as the amplitude goes, I measure how far I move up or down from the baseline. So the amplitude here is 2 units. This lets me calculate what my what my A value is going to be, what my B and C values, or my B and D values are going to be. So if I know the period's 2 pi over 3, and I calculate the period by doing 2 pi over B, I know that B is going to equal 3. Since y equals 0 is the baseline, it means that D is going to equal 0. And since the amplitude is 2, I know that A is either going to be a plus or minus 2. Now, which one it's going to be is going to be, again, based on decisions that I make along the way. Because the only thing I haven't figured out yet is a phase shift. Well, a phase shift is going to be dependent upon what I choose to be a starting point. Now, keep in mind, we typically like to start these graphs at the y-axis. So if I can start the graph at the y-axis, I'll certainly try to do that. And for me to have a starting point on the y-axis means the graph either has to be at its highest point when it's at the y-axis, its lowest point when it's at the y-axis, or be at the baseline when it's at the y-axis. And if you look here, this graph is doing none of that. It's crossing the y-axis right here. Okay? That's not a highest point, it's not a lowest point, and it's not on the baseline. So I'm going to have to choose a quote-unquote starting point. And that's going to make me choose my phase shift. So, and my choice of phase shift is going to change my value of C. It's also going to change my value of A as far as being positive or negative. So let me show you. For instance, say I choose this point to be my quote-unquote starting point, where this purple dot is now. I'm letting my phase shift be negative 3 pi over 4. Now, I know that that's calculated by doing negative C over B, and I've already figured out that B was 3 before, so I would solve this little equation here. Negative C divided by 3 equals negative 3 pi over 4. Multiply both sides by negative 3, I get that C is 9 pi over 4. Okay, so that gives me the C value I need. At this point, I also notice that if I'm starting here and moving to the right, I'm following a cosine function, because I'm starting at a highest point, going to a lowest point, returning back to a highest point. So, a cosine graph starts at a highest point. So I'm going to be using cosine for my trig function value, and since it starts where a above the baseline, where a cosine graph typically does, there is no reversal. So I can say that one equation for this would be y equals 2 times the cosine of 3x plus 9 pi over 4. And if you graphed it, you would see pretty much the same graph. But what if I didn't want to choose negative 3 pi over 4 as my starting point and therefore my phase shift? Hold on one second. Another choice I could have done for this is I could have chosen negative pi over 4, which is right about here, to be my phase shift. Because that starting point would be on the baseline. And I know exactly where it is. Now, that's going to change a couple of things. It's going to change what I calculate to be C. Because now negative C divided by 3, because B is still 3, is going to be negative pi over 4. I multiply both sides by negative 3. I get that C is 3 pi over 4. Another thing that's going to change is that, well, since I'm starting on the baseline, that's no longer a cosine function, that's a sine function, because sine functions start on the baseline. So it's going to change my trig function value, or the trig function I use. So now, as I move from pi over 4, I move up, then down, then up again. That's how a sine function usually does behave, so there's no reversal. So a will be a positive 2. So my formula, my equation, if I use that as my starting point, would be y equals 2 times the sine of 3x plus 3 pi over 4. If you graph these two things together on a graphing calculator, they would be exactly the same. You would not notice a difference. But what if I didn't want to choose any of those two? Say I chose positive pi over 4 as a starting point. Again, I can start at a lowest point. That's perfectly fine. Okay? Now again, if my phase shift is pi over 4, that means C is now going to be a negative 3 pi over 4. So my C value has changed. Since I'm not starting on the baseline, I'm starting at an extreme point, which we often call it. Either a maximum or a minimum is called an extreme point. I'm going to be following a cosine function, and cosine functions typically start at the highest point. If I'm starting at the lowest point, that means I have a reversal. So a is now going to be negative 2. I'm going to be using the cosine function, so now an equation I can have is y equals negative 2 times the cosine of 3x minus 3 pi over 4. Again, all three of these, if I were to graph each one individually, would produce the exact same graph. And lastly, just to show you another one, what if I had chosen this point over here, 3 pi over 4, as my phase? Again, it's a baseline point, so that's a legitimate starting point to make use of. Now again, it's going to affect my calculation of C, because again, negative C over 3 is going to equal 3 pi over 4. I solve that equation for C, I get a negative 9 pi over 4. But since I'm starting on the baseline, I'm going to be using a sine function. And since I'm starting there and moving down first, then up, whereas a sine function usually moves up, then down, and this is always going from left to right, mind you, I do have a reversal. So a is going to be negative 2, so another possible equation is y equals negative 2 times the sine of 3x minus 9 pi over 4. Now, you did not have to produce all four of these to answer the question, because the question only asks write an equation. So any one of these would be a correct answer. But notice there could be some differences in final answers depending on what you chose to be the starting point or the phase shift. Again, one way of making it a little easier on yourself is if you have the option of using no phase shift at all, it makes your life a lot easier. You don't have to calculate a C value. But again, you want to make for that to happen, your highest point, your lowest point, or a baseline point has to be on the y-axis. If that's not the case, like it was here, I have to choose my own starting point.